Hello everyone, Mr. Schultz here. Today we're going to do Integrated 1, 4-2, Rate of Change. Rate change is going to be rise over run, also known as slope. So let's write that in. Slope. Basically, we can figure out what is the slope from the change in x under the change in y, or the change in y over the x. Basically, how do we do that? Well, 12 to 24 is plus 12. 12 to 24 to 36 is plus 12. Okay. 2 to 4 is plus 2. 4 to 6 is plus 2. So in each of these cases, it changes plus 2, plus 12, plus 2, plus 12. Our delta y, our change in our rise, is 12. Our change in x, our run, is going to be 2. In each of these cases, it's the same fraction, same rate. It's 12 over 2, or 6 over 1, or just 6. But technically, it's 6 over 1. This has a constant rate of change. So this is a linear equation. It's also a function, but we'll get to that later. Let's go on. Let's look at the next two right here. Basically, all we have to do is we have to figure out, does the change in y over change in x change? Or does it stay the same? So, negative 5 to 3, that's going to be plus 2. Negative 3 to negative 1, that's going to be plus 2. Negative 1 to 1, hey, it's still plus 2. And plus 2. Since each one of these is the same, if the x change stays the same as well throughout, then this has a constant rate of change as well. Let's see if it does. 11 to 8 is going to be minus 3. Okay, it's going to be a negative slope. 8 to 5 is negative 3. 5 to 2 is minus 3. 2 to negative 1 is minus 3. Now, we might not like it because it's a negative slope, but who cares? This has the same slope. It has a constant rate of change. So this has a constant rate of change. So it is a linear equation, a function. So let's go on. So the next one, negative 4 to negative 1, that's going to be plus 3. Negative 1 to 1, plus 2. To get from 1 to 4, that's going to be plus 3. To get to 4 to 6, that's going to be plus 2. All right, so I know from 22 to 29, that's plus 7. 29 to 36, that's going to be plus 7. Wait a second there. So it goes 3 over 7, or delta y over delta x is 3 over 7, then it's 2 over 7, and then 36 to 43 is plus 7 again, and then plus 7. It looks like it's trying to tell us, hey, these are going to be the same, but if we know fractions, we know 3/7 is not the same thing as 2/7. So this does not have a constant rate. So it is, we're going to throw in not a linear equation. Now, it might still be a function, but it's not a linear equation because it doesn't make a line. Because it needs to have a constant rate of change for it to be a line. It has to have the same slope. Let's go on. Example 2. Compare rates of change. So looking at this might be a function, but it is not a linear equation or linear function because this is going to have different rates of change. We can tell that because it's not a straight line. That's pretty much it. From the graph, we know it's not. And what's going to show us that? If we take this information and we find out what is the rate of change, we'll see that it changes. All right, find the rate of change from 2000 to 2005. All right, well, I know that I want my delta y over my delta x. So from 2000 to 2005, that's my x. So from 2000 to 2005, that's going to be 5 years. Well, okay, it's going to go from 1350 to 1675. Well, I'm just going to subtract these two. If I subtract these two, I'll get 325. So what is the meaning in this context? Well, I would say that the dollars increase, the dollars in the budget increases $325 over 5 years. There it goes. In the 5 years, it increased $325. Well, we can see this from this slope. In 5 years, it increases by $325. Now, if we're attending to mathematical precision, maybe we should have written in our units of measurement, because that's what it needs to have. We should have written it in, but we tend to forget to do that because in math land, we normally just go numbers, numbers, numbers. We don't care about anything else. Just give us the numbers. But we need to understand there's information besides just the numbers. There's the units, rates, or the units of measurement. There we go. Thank you. Let's go on. Find the rate of change from 210 to 215. All right, well, from 210 to 215, we can see that it's going to be our delta y over delta x. It's another change in 5 years, but it goes from 1550 to 1325. If we understand that it's a negative slope, it's going down. So if I subtract this, I know that it's going to be negative. I go 1325 minus 550. If I subtract that, I should get negative 225. But we forgot the unit of measurement. It's negative 225 what? Dollars. So I'm going to squeeze that in right there. And once again, it's asking, hey, what's the situation? Well, over 5 years, so over the 5 years from 2010 to 2015, the high school budget went down $225. Now, as long as we're saying, hey, it's going down, we don't need to say, hey, it's negative, because we don't have negative dollars. We can say, hey, it went down this much, but we don't want to really say that it's negative 225. All right, let's go on. All right, so we're going to talk about what is slope. Slope is pretty much going to be, rise over run. This is what we know as the delta y over the delta x, or the change in y over the change in x. Pretty much, if you take, it doesn't matter which one you use, but if you have 2 points, x1, y1, and x2 comma y2, you could subtract them out and you could figure out, all right, I'm going to take the y of this, subtract that, and the x of this and subtract that, and you will get the rise over run. But sometimes we forget that. So let's just take an example. Let's take -4 comma -3. So this is -4 comma -3. Now let's just pick a random one. Let's say 3 comma 4. So basically what we have to figure out, we have to understand what is the rise over the run. Well, this is where we come with the slope triangles. We figure out how much up does it go. After that, how much to the right does it go? That's the rise over the run. So we could literally just count up, -3 to 3. We'd be like, okay, -2, -1, 0, 1, 2, 3. Or how much, we just figure out, hey, you're at -3 and you go to 3. What difference is that? It's going to be 6. And you're at -4 and you're going to go to 4. What's that? That's 8. Because you go to 0. Oh, no. Sorry, I miss. It's not 4. And it's not 3. So let's go back and find the errors. Let's erase those. Sorry. It's not. It doesn't go up to 6. It goes up to 4. So I sometimes will flip my numbers a little bit. It's at -3. So the y, it's at -3. And then it's going to go to 4. So that goes up 7. Sorry, guys. And then it's at -4. And it goes to 3. So that goes over 7. Well, let's test that. Count the boxes. 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah, that works. All right, so if we take this, we understand that the delta y of this is going to be up 7, and the delta x of this is going to be over 7. So our slope for this would be 1 over 1, or just 1. So just remember that we're trying to find the slope. How much up to how much over. All right, let's go on. So example 5 and 6. So if in your homework it says, hey, this deals with example 5 or 6, we're talking about positive and negative slopes. So it says, find the slope of a line that passes through -3, 4, and 1, 7. So what I like to do is I like to draw a short thing, and I go, okay, this is -3, 4. And this is 1, 7. I like to do a visual type thing. So I know, so I'm going to have my delta y over delta x. I know that's what my slope is. So it's going to go from -3 to 1. Well, what's the distance if it goes from -3 to 1? Well, that would be 4. So that means my x is 4. So if it starts at 4, now here's my y. If it starts at 4 and it goes up to 7, how much up did it go? Well, it went up 3. So here's the question. Is 3 divided by 4 a positive or negative number? It's a positive number. So therefore, this has a positive slope. So even if I draw it wrong and I'm like, all right, I'm going to start at -1, 3. And I'm going to go up to 4, 1. Even if I draw it wrong, which we will see, it's okay. As long as I have my visual understanding and say, okay, I get this. So I'm going to start at, let's do the x. I'm going to start at -1. I'm going to go to 4. Well, -1 to 0 is 1. Then to 4 is 4 more, so that's 5. So my run is 5. It's looking good so far. Now from 3 to 1, I'd be minusing 2. Okay, so I know if I only have one negative, it's going to be negative. So this would be an example of a negative slope. All right, guys. So positive slopes look a certain way, negative slopes look a different way. Just understand that positive slopes or negative slopes, they're going to look a certain way, but hey, we will talk about that in class. See you guys. We're going to go on to the next example. Example 7. The slope of horizontal lines. So sometimes we're going to have horizontal lines. So in this case, we have something that's at -2, -5, and it's going to go to 4, -5. So how much up over how much over? Now, at this point, I would say, hey, you should probably be using a calculator to figure out, hey, what is the slope? Because this will give you a nice hint. So it doesn't go up or down or anything, so the rise is 0, and it goes from -2 to 4, so 6. 0 divided, if you use a calculator, you'll see that 0 divided by 6 is 0. So this has a slope of 0. So m is equal to 0. For this equation right here, this would be y is equal to 0x minus 5. Or just y equals -5. Alright, let's go on. We're going to talk about a vertical line now. Example 8. Alright, example 8. What if we have a slope of a line that passes through -3, 4, and -3, -2? Well, this is going to be a undefined. Now the problem with this is r delta y over delta x. Now from -2 to 4, it doesn't matter which one we go, but let's say we're going from 4 to -2. Sure, why not? If we're going 4 to -2, that's going to be -6. Sure, why not? And -3, it doesn't move left, doesn't move right, so it's going to be 0. Now at this point, if we plug this into the calculator, we would see, hey, it's undefined. Now, I'm going to tell you right now, there's a reason why this is. And we can see that when we get to pre-calculus with limits and stuff, but basically, like, as it gets closer to a certain number, something's going to happen, but we will talk about that in a later class. I can also post this on the Edpuzzle as well to give you a hint of, hey, this is what you would see. Alright, last one, let's go on. Alright, use intercepts. What is the slope of the continental slope at Cape Hatteras? Alright, well, basically, they're going to give us 2 points, and we just have to figure out what the slope is? Sure, why not? So, we're going to write down delta y over delta x. So, my delta x, it goes from 75 to 125. Okay, well, from 75 to 125, I know I would add 50. So, I'm going to put 50. And then from -65, it's going to go to -2,700. All right, well, I know at this point I should probably use a calculator and figure out, all right, I'm going to take, so I know that, hey, I'm going to go from -65, the difference in between those two numbers, subtracting, would be -2,700 plus 65, because minus. So I'd be like this number minus this number. And so I would get -2,635. But wait, there's more. We didn't really explain what each one is. Well, I mean, it's still meters and meters. Well, let's explain that. What is this? Does this mean in the terms of are intercepts. Well, I don't think it's intercepts, but what does this mean? Well, this means that it sinks down, so the continental slope goes down 2,635 meters while only going 50 meters up. So it goes down a tremendous amount before it goes, while it's going 50 meters out. That's about it. All right, guys. Thank you for watching. I hope you have a wonderful day. See you in class. Bye.